Hello, my dear students. I understand you have a question or two or 20 about the assignment from chapter 18. So let's dig right into number 11. They're telling us in the 2013 analysis, 1,215 samples of seafood purchased across the U.S. found out that 33% of it was mislabeled. What? Um, Goodness gracious, that's scary. For Part A, construct a 95% confidence interval for the proportion of all seafood sold in the United States that is mislabeled or misidentified. Okay, so as we're going through the process here of constructing our confidence interval, we have to be careful that we first of all meet the conditions. Okay, and again, in your book, they went ahead and described several of them. The randomization condition, well, the way they phrased the question, it's not really clear. Um, but for the sake of argument, let's give them the benefit of the doubt. And when they did their survey, that the ones that they tested are representative of all seafood packages. Then we have the 10% condition. Okay. The next one is the 10% condition. Now, if we're going to go ahead and say they analyzed 1,215 samples of seafood um, compared to how much is sold in the country, I think that that would be safe to say that the 1,215 is probably less than 10% of all of the packages of seafood that were sold in the United States. So we're okay with that. Then we need to check the success failure condition. And for this one, you actually need to do some calculations and write some of this stuff out. Okay. So in our case here, p hat will be 0.33. And I think they then talk about the converse being q hat. So that'll be 0.67. For the success failure condition, we've got to take the sample size, the 1,215, and multiply it by both of these. So 1215 times 0.33, that'll give us 400.95. The 1215 times 0.67 will give us 814.05. And both of these have to be greater than or equal to 10. Both of them are. That condition is satisfied. So you would write something like the sample size is large enough. All right, so then now that we've satisfied those three basic conditions, we can proceed and construct a 95% confidence interval. Um, so we're going to start with, again, our lovely formula says we're supposed to start with p hat, which is the 0.33. Plus or minus is how we're going to get the interval, the upper and lower bounds of this. Now, a lot of you had a question about that z-star number. We're supposed to construct a 95% confidence interval for the proportion here. So a 95% confidence interval. Unfortunately, that's not a function that Texas Instruments or anybody else really has programmed into their calculators to do quickly and easily. These critical values, the z stars, are either something that you're going to have to commit to memory, or he says, go to your exam formulas, go to the table of values, think I pointed this out on a previous video. Scroll past table A on through table B, but wait, down there at the very bottom. Okay. In this case, if we're looking for a 95% confidence interval, read the row right above it there. Our Z star value in this case is the 1.960. Okay, so again, 95, that's our critical value that we need to use. Now, my understanding again is that when you take the actual exam, you will have access to this. So I don't know if you just want to make sure that you've got your OneNote open to this particular tab. Um, the College Board people also suggest that you might want to just print them out. Yeah, I'm not going to tell you what to do as far as that's concerned. Okay, so again, not something that shows up on the calculator easily, but it is something that you can get by referring to table B. Okay, so the 1.96, don't want to leave that completely messed up. That's our Z star value here, 1.96. Then we have to multiply that by our standard error, which means the lovely square root. We've got to take p hat times q hat divided by n. So in this case, 0.33 times 0.67 divided by our sample size of the 1215. And my, that's a mess. Let's get the calculator. For fear of typing something in wrong and screwing it all up, I usually try and break it down into steps here. So here's the standard error, 0.33 times 0.76 divided by n. Okay, and now I need to take that and multiply it by my critical value of 1.96. And then this minuscule thing is what we're going to add to and subtract from our p hat, the given 33% value. So if we take 0.33 and add that previous answer, that'll give us an upper bound of, oh, let's go 4 decimal places here, 0.3564. And let's take the 0.33. Unfortunately, I'm going to have to retype this, 0.02644. And we can say our lower bound there is 0.3036. So this is our 95% confidence interval for the proportion of all seafood sold in the United States that's mislabeled or misidentified. As usual, then they're going to ask you to interpret what is the significance of this interval, this group of numbers that you created here in context. Okay, so you would have to write out something. I'm 95% that, sorry, 95% confident that between 30.36%, now in this case, sorry, the form of your numbers, I think it's completely appropriate. The question was given in terms of percentages. To write out your interpretation, the part B, and go back and convert the decimals in your confidence interval for part A into percentages for part B. So between 33.36% and 35.64% of all seafood in the United States is mislabeled or misidentified. Then for part C, a 2009 report by the GAO. Again, if you've been paying attention to the news, you've heard of these people. I've heard of these people mentioned frequently. says that the FDA has spent very little time recently looking for seafood fraud, suppose an official had said. That's only 1,215 packages out of billions of pieces of seafood sold in a year. With the small number tested, I don't know that one would want to change one's buying habits. Now, note there, that's not the exact quote in this situation, but it's amazingly similar to something that an official did say in a very similar context. Is this argument valid? No, no, it's not. Because, again, if this environmental group, in fact, did a representative random sample of 1,215 pieces of packages of seafood, that small number meets our technical conditions here. And yes, this analysis can be valid. Number 14. Pew Research in 2015 polled a random sample of 1,060 U.S. teens between the ages of 13 and 17 about internet use. 56% of those teens reported going online several times a day. If you're an advertiser, you want to know that. Explain the meaning of p hat in the context of this situation. So that means 56% of the 1,060 teens in the sample said that they go online several times per day. This is our best estimate of P, the actual proportion of the population of all US teens. Okay? So again, be very careful on the AP exam that it's not saying 56% of all teenagers. No. 56% of the 1,060 teens in this sample. Okay? Make sure you quote, and if you can, refer to the number of the sample size there. Quote that directly. Part B, calculate the standard error of p hat. Okay, so again, our standard error here is just what we just looked at there for number 11, the part that's underneath the square root symbol. Okay, so they gave us the proportion there. P hat is 0.56, so Q hat has to be the complement, 0.44. Divide by the sample size n was 1060. Crunch the numbers. There we have it. Again, that's standard error. Because this comes from our sample, we can't say it's the standard deviation. Remember, there's a slight change there in terms. Explain what this standard error means in the context of this situation. Again, we don't know the value for P, so we're substituting P hat, the proportion from the sample, from the survey, to estimate the standard deviation. Standard error is our estimate of the amount of variation in the sample proportion that we would expect to see. Again, sample variability. From sample to sample, when we would ask that same size whether they go online several times per day. I know that's wordy, and that's exactly what they're looking for on the test. Teenage drivers. Why do we talk about teenagers so much? An insurance company checks police records on 582 accidents selected at random. Teenagers were at the wheel in 91 of them. What? Create 95% confidence interval for the percentage of all auto accidents that involve teenage drivers. So again, we start with our conditions here. Are they independent? Well, okay. Of the accidents selected at random, yeah, there's nothing that indicates one would be related to another. The insurance company randomly selected. I do believe they mentioned that. They selected at random. So that condition is met. 582 accidents. Yeah, that definitely represents less than 10% of all accidents in the United States. Our success failure condition, again, you have to show your calculations. So if we're saying 91% of the 582, well, that means n times p hat would be 91. Okay, you really don't have to plug that into a calculator, I hope, but you have to write this out. They will take off points if you don't write this out. And then the sample size times q hat. Okay, let's take 582 and subtract 91, and that gives us 491. Both are greater than 10, so the sample size is large enough. You have to write out all of those conditions. And again, in some cases here, you've got to demonstrate with numbers. A lot of it, you've got to demonstrate that this condition is met in written form. All right, so let's do our confidence interval here. And notice how they get really, really lazy and they didn't even convert these into percentages for you. Yeah, your calculator will handle that for you. Okay, it's just the tediousness of typing it in twice. So hopefully you got somewhere between 12.7% and 18.6%. And then explain what this means. We are 95% confident that between 12.7% and 18.6% of all accidents involve teenagers. We don't know what that exact value is. We are trying to come up with an interval, a range of values here that captures that actual population proportion. What's the 95% confident means? Well, if we take more samples, randomly choose, sample size should be the same, 582 accidents, about 95% of those random samples will give us intervals that contain the true proportion. Again, we're trying to estimate that. 95% of the random samples of this same size will give us an interval that captures P, not P hat, accidents involving teenagers. Part D, politician urging tighter restrictions on driver's licenses issued to teenagers said, in one of every 5 auto accidents, a teenager is behind the wheel. Wait, hold on. 1 out of every 5 auto accidents, that'd be 20%. That's not right. If we're saying, here's our interval, 20% is outside of that interval, brace yourself. The politician was exaggerating. Lots of questions about 25, so let's go on to that one. 2017 Gallup poll found 29% of American adults have a favorable view of the federal government. Wow, 29%. That was the highest proportion since they started asking the questions in 2009. I'm joking. They've been asking that for decades. It is based on a random sample of 529 US adults. So they're asking you, again, let's practice building a confidence interval for the proportion of Americans who had a favorable view of the federal government in 2017. It is, first of all, for independence assumption. The randomly selected 529 people are mutually independent. 529 adults, it said that they were chosen at random. 529 is definitely less than 10% of all US adults. Your success failure condition here, this time you would have to write out the work. Showing sample size is 529, p hat is 0.29, so that product gives us about 153. N times q hat gives us about 376. Both are greater than 10. Sample size is large enough. We have met all the conditions. We are approved to proceed. So again, 0.29. Now, again, a lot of you are asking, what is the deal with that? We were told 90% confidence interval. So if we go back to our formulas, our tables, 90% confidence gives us a critical value there. Your Z star confidence level went down, so that Z star number goes down also, 1.645. Sorry. 1.645. Hey, look, things are connecting. How exciting. And again, p hat 0.29, q hat 0.71, sample size n is 529, so that'll give us something between 25.7 and 32.3%. Again, what does this mean in context? We are 90% confident that between 25.7% and 32.2% of all U.S. adults have a favorable view of the federal government. The 90% confidence level means that, again, between those two numbers, a random sample of the same size will produce confidence intervals that contain the true proportion of U.S. adults who have a favorable view of the federal government. Again, we're trying to capture it. We can't nail it down to just a single value. Here's this range for our 90% confidence interval based on this one survey. 90% of other random samples of the same size will also successfully capture that true proportion, even though we don't know what it is. Do these data refute the pundits' claim that fewer than 1/4 of Americans have a favorable view of the federal government? Well, yeah, if you look at our confidence interval there, 1/4 is 25%. Yeah, that's below our confidence interval. So, yes, the person's claim fewer than 1/4 of Americans have a favorable view of the government would be accurate. And then good old number 30. I think this was hands down the winner in our online voting of which one's the most confusing. All right, it's believed, graduation. I'm sorry if this is a sore subject. It's believed that as many as 25% of adults over 50 never graduated from high school. We wish to see if this percentage is the same among the 25 to 30-year-old age group. So now the question becomes, how many of this younger age group must we survey in order to estimate the proportion of non-graduates within 6% with 90% confidence? Okay, so when they said that 6%, that was a clue. That's the phrase that's used there. What they're describing is the margin of error. Now, as far as building our confidence interval, it's the second part of it. The first part is p hat, then we got the plus or minus. It's everything after the plus or minus that's called the margin of error. So we've got to take the z star times the standard error. Okay, so they start by refreshing your memory of that lovely little formula. Okay, so again, if the question asked for a 90% confidence interval, 90%, we need a z star of 1.645. You see that right here. They're saying 25% of adults over age 50 never graduated from high school. So that 25%, that becomes our p hat. Q hat then 75 over, now here's your one and only variable. They're asking you to calculate what the sample size has to be to get this margin of error. So we put in the 0.06 in place of the margin of error. So once we get to this point, we substitute in every value that we know. So out of those 5, we know the value for 4 of them. And again, 1 came from the table, not the problem. And we need to solve that for n. So now it's a matter of using your algebra skills. And then they do voodoo to flip the fraction, solve it for n. Oh my goodness. Yeah, n's in the denominator there, so you're gonna get rid of the square root just by squaring everything. Okay, the things that were outside the square root, the 0.06, that gets squared. The 1.645, that gets squared. The 0.25 and 0.75 were under the square root, so those don't get squared. Multiply both sides by n, divide by the 0.06 squared. And that's how they did that. And then, yeah, technology voodoo. 141 people. So again, in order to estimate the proportion of non-graduates in the 25 to 30-year-old range within a 6% margin of error with 90% confidence, we would need to sample at least 141 people. Yeah, round that up. Don't round it off, round it up to the next person. For a more cautious answer, well, that's interesting. If we went with 0.5 for p hat, then q hat would be 0.5 also. And that really doesn't involve very many more people, 188 compared to 141. Okay. So again, it's very algebra intensive on this one. Suppose we want to cut the margin of error to 4%. So if the margin of error goes down, the sample size has to go up. Okay, so basically they did the same kind of voodoo. Sticking with a 90% confidence interval, the z star is still the 1.645, but we've now dropped the margin of error from 6% down to 4%. Same type of algebra, 318 people. Okay. Then again, they put that off to the side. Now, again, this little part here, oops, I take that back. This part here, that's another way of going through it there, but again, I don't know how many of you would think your way through it like that. We went from 0.06 to 0.04. I'm afraid too many people would just take the difference between them, and that's horrible. The margin of error is 2/3 of the original. So because again, the sample size is what we're looking for here, and it's flipped upside down, you got to take the 2/3, square it, and take its reciprocal. Yeah, I don't know how many of you would think like that. And one more time, sample size get down to a margin of error of only 3%. Again, do the same voodoo. 564. So if we're reducing the margin of error and keeping everything else the same, we have to increase the sample size. Okay, so hopefully you can see the pattern there going from 141 to 318 to 564. Okay, hopefully that clears things up. Take some time to review and then go on over to the Pearson website, and there should be a quiz waiting for you. Good luck.